Triangle law and parallelogram law. I am Datta Sir, ex-senior professor of #1 IIT-JEE Institute of India. In my 30 years experience, I have seen that the students have faced many problems in various small concepts. So I have decided to make videos on this for the benefit of the students. If you are one of them, it will be very helpful to you. Please see this video very carefully. And if you are benefited, like this video and also share this video to others so that they can also be benefited. Moreover, I will be posting this type of videos on a regular basis, and therefore I request you to subscribe this channel and press the bell icon so that whenever a new video is posted, you get the information. So let me go to the topic. See, today's topic is vector addition, triangle law and parallelogram law. See, vectors have magnitude as well as direction. So they cannot be added like scalars. So there are two laws relating to their addition. One is triangle law, one is parallelogram law. So we have to understand that. In the picture, first picture, you see that ABC is a triangle. In this, AB and BC are two vectors joined end to end. So that in that case, AC will be the resultant, means vector sum of AB and BC. So the rule states that if two vectors are represented by two adjacent sides of a triangle taken in the same order. What does it mean? Taken in the same order means they are added head to tail. So if they are taken in the same order, then the third side taken in the reverse order will give the resultant of these two vectors. Now here the third side is AC, but if it is also taken in the same order, then it becomes CA. But we have to take the third side in reverse order. So that we have to take AC, not CA. So AC becomes the vector sum of AB and BC, not CA. Next comes the parallelogram law. It says if two vectors are represented by two adjacent sides of a parallelogram, then the diagonal passing through the point of intersection of the vectors will represent the resultant. Here AB and AC. Here they are not connected head to tail. Here they are connected tail to tail. And the diagonal passing through their point of intersection is AD. Now a parallelogram has two diagonals. See, here also there is a diagonal AD and there will be another diagonal BC. But we will not take BC, we will take AD, because the parallelogram law says if two vectors are represented by adjacent sides of a parallelogram, then the diagonal passing through the point of intersection will represent the resultant of the two vectors. See, actually the both laws are same. Both laws are same, only they are stated in different way. See, in this parallelogram, see AB and AC are two vectors. Now, we know that a vector can be shifted from one place to another if their direction and magnitude remain same. Now, AC and BD are two lines in which are parallel and equal. So, if a vector is represented by BD, that will be equal to AC vectors. So, we know already that by triangle law, here AB plus BD is AD and BD is now becoming equal to AC. So AB plus AC is also AD. That means both the laws give the same result. Only when the vectors are connected head to tail, we will apply triangle law. When they are connected head to head or tail to tail, we will apply parallelogram law. So these are the simple statements of the two laws, and that is the most basic rule for the vector addition. Now, if we have to find the magnitude of the resultant, then we have to deduce, but I am not showing the deduction here because that you can find anywhere. The magnitude of the resultant will be nothing but root over of AB square. If AB and BC are the magnitude of AB vector and BC vector, then the resultant has a magnitude which is equal to root over AB square plus BC square plus 2 into AB into BC into cos theta. What is theta? Theta is the angle between the vectors. Now, one very important point. What is the angle between the vectors? To find the angle between the vectors, we have to place them either tail to tail or head to head. But suppose in the triangle AB and BC, they are placed head to tail. So this ABC also an angle, but that is not the angle between the vectors. If we take ABC as the angle between the vectors, we will be wrong. That will be the angle other side of this, because if AB is extended, we get another angle, that is theta. We will have to take that theta. Similarly, everywhere in the case of parallelogram also, but in the diagram there is a small mistake. The theta here is given between AB and AD in the parallelogram, but actually correct the mistake. It will be the angle between AB and AC. If this is an angle between AB and AC, then we can put it in that formula. Now there are three special cases. If theta is 0, then its value becomes simply AB plus BC. Means we can add vectors which are in same direction, we can add them just like scalars. If theta is 180, means if the vectors are just opposite and in same line, the magnitude will be just the subtraction of their magnitude. But if they are at 90 degree, then magnitude will be given by root over AB square plus BC square, because that is from the Pythagoras theorem. So this is about the triangle law, parallelogram law of vector addition. So I will come to you with some other concept in other video. For this video, up to this much today.